Welcome to Target IAS. I am Prakash Rajput, and today we will see method of images, or we can say this as image theory. Method of images or image theory. So, what is this basically? It's image theory states that the q charge near by a conducting surface nearby a conducting surface is replaced by itself is replaced by itself, that is the plus q charge or the q charge, and its image charge. So image charge will be minus q. This itself charge is this. Suppose this charge is plus q, so its image charge minus q, so that the conducting surface is replaced by a equipotential surface equipotential surface, either 0 volt or constant voltage something. So here this is the statement of image theory. So what it actually means is, if you try to understand, suppose a charge is placed here, and here some conducting plane, infinite conducting plane is placed. This is infinite conducting plane. If I make this figure in three-dimensional, then it will be something like this. So this is infinite conducting plane, perfect conductor है ये, infinite perfect conducting plane, and here plus q charge is present. Suppose this is grounded, infinite uh, conducting plane which is grounded. So by image theory, this thing can be replaced this thing can be replaced by a equipotential surface, which is this conducting plane. The charge itself at q, suppose this is at distance d, so here also the distance remains d, and its image, which is, so image भी same distance पर होगी, so its image will be minus q. So this thing will be given by image theory. अगर कोई conducting plane है और एक point charge या कोई भी line charge भी है अगर, ठीक है ना, सिर्फ point charge, अगर कोई line charge भी है, suppose करते हैं plus rho l का, तो उसको भी replace करने के लिए इसकी image, which is of minus rho l density, will be placed at the same distance. और कोई अदर चार्ज डिस्ट्रीब्यूशन है, सपोज कर लेते हैं सरफेस है अगर, ठीक है, पॉजिटिवली चार्ज, सपोज रो एस, so it can be simply replaced here by its image, which is of minus rho s. और अगर कोई वॉल्यूम चार्ज भी है, अगर कोई वॉल्यूम चार्ज भी है, same like sphere, so it will be also at same distance but with opposite sign. Suppose this has rho v volume charge density, and this will be having minus rho v charge density. Okay, so if we want to apply image theory in presence of some charge distribution and a perfect conducting plane conducting plane, so we have certain conditions to fulfill to apply that. The first condition is that charge should be the charge should be placed such that it is such that it is lying lying in the region or area of conducting surface. इस कंडक्टिंग सरफेस कंडक्टिंग प्लेन के अंडर जो एरिया आता है उस पर अगर चार्ज प्लेस्ड है ऊपर या नीचे, तो हम इमेज थ्योरी अप्लाई कर सकते हैं बाय रिप्लेसिंग द चार्ज इटसेल्फ एंड द कंडक्टिंग प्लेन विल बी replaced by equipotent surface and its image charge at the same distance on the opposite side. So we can apply in this condition the image theory. Now there is another condition, that is the the image charge must be located such that on the conducting surface on the conducting surface the potential will be zero or constant. पोटेंशियल विल बी जीरो और कांस्टेंट. इस तरीके से कुछ इमेज चार्ज को प्लेस करना है तो सेम डिस्टेंस पर ही प्लेस करेंगे. सो दिस इज हाउ यू कैन अप्लाई द इमेज थ्योरी. सो कोई भी चार्ज डिस्ट्रीब्यूशन हो और परफेक्ट कंडक्टिंग प्लेन हो, उसके ऊपर कोई चार्ज डिस्ट्रीब्यूशन है, तो किस तरीके से आप इमेज चार्जेस को प्लेस कर सकते हैं वो है. नाउ लेट अस सी one question regarding this. So here is one question. Find magnitude of force on charge Q naught in the figure. So here there are two identical charges Q naught Q naught. So I have to find force on first charge. Like we can find on anyone the force. So here this surface z equals to 0 surface is a perfect conducting plane and the charges are placed on it like this. So we can apply image theory here. We can apply image theory here and we can make equivalent charge diagram, we can say, of this by using image theory. This conducting surface will be replaced by an equipotential surface and here a charge q naught is placed. Here another charge q naught is placed. The distance between them is d and this distance is d by 2. This distance is d by 2. Up till here the diagram is almost same. Now at the same distance from here to like d by 2, another charge which is minus q naught because of this will be placed here, and because of this another charge minus q naught will be placed here at the same distance. So suppose it is on coordinate axis and we can write points of these if we take this line as the z-axis line and this line as the y-axis line. So what will be the coordinate of this? The y value is 0 for this, and suppose the charges are lying in the yz plane, so x value will be 0. So here 0 0 for z it will be d by 2, and for this it will be 0 0 minus d by 2. I can write because it is below z equals to 0, and here the y value will be d because it is from the z axis, they are here. Distance is d, so the coordinates of this will be 0, d, d by 2, and for this it will be 0, and y value will be d and minus d by 2, right? So I have to find force on this charge due to all these charges. So what I can do, I can find force due to this one F1, due to this one F2, and due to this one F3. So that and the total force will be sum of all the forces. So let us find first F1. F equals to, total force equals to F1 plus F2 plus F3, right? F1 plus F2 plus F3. So F1 will be what? F1 due to the first charge here. It will be, as the charges are of the same polarity, so I can write Q naught, Q naught, and in place of 4 pi epsilon naught I will be writing K, and the distance between them is d square, right? So what will be the direction? So you can easily find out by force location minus the source location. So if you find the displacement vector, it will be coming minus d from here, 0 minus d, force location minus source location, minus d ay cap, because I am assuming this as my y axis and this is my z axis. So this will be the force due to F1. Now here I have written this minus d ay cap, so I have to put like d here for the magnitude, right? So I can directly cancel this, I will do this later. F2 due to, suppose this charge minus q naught here, so the value will be k q naught minus q naught by r square. The distance between them is what? Root 2 d, because you can see this is like a square. Here this distance is d, this distance is d, so this distance from here to here will be what? Root 2 d, right? So k cube, I can directly write here cube, and the r12 vector, that will be force location minus source location, so it will be minus d ay cap, minus d ay cap, and d minus 2 plus d plus d az cap. Okay, another one, that will be due to this minus q naught divided by the distance here is d, so I can write d cube, and the unit vector will be it will be d az cap, d az cap. Now after let us simplify this. So you can take k q naught square common from all these things, and in all the cases d cube is also common, d cube is also common, but here this d gets cancelled with this d, and here also I can take d common and make d make 1d cancel. Here also same thing, so I can take common k q naught square divided by d square, and the remaining thing here it will be minus ay cap. Here what is remaining? uh, this minus, if I multiply this, it will be plus ay cap, and here it will be minus az cap by root 2 cube, that is 2 root 2, root 2 cube, that is 2 root 2, and here it will be minus az cap, here this will be minus az cap, right? So now what I have to do, I have to find magnitude, I have to find magnitude. So I can find the magnitude of using this. It will be, if I write f magnitude, so it will be k q naught square by d square, and magnitude of this, so collecting the components here, ay cap component are 1 by 2 root 2 minus 1 whole square plus, here all these components are in minus, so I can write 1 by 2 root 2 plus 1 whole square. And if you simplify this, the thing that will come is, if after simplifying this, it will be k q square by d square, and here after solving this 3 by 2 will come, so this will be the magnitude. And if I write in 4 pi epsilon form, that will be 3q naught here actually, 3q naught square divided by 4 pi epsilon naught multiplied with this 2 becomes 8 pi epsilon naught d square. So this will be the final expression of what, the force magnitude on the charge q naught. Hope you understood like how to apply the image theory, like, right. Now if the surfaces, if the conducting surfaces are like this, here this is like a semi infinite conducting plane, and this also a semi infinite conducting plane. Now a charge is placed here, then how many images you can form? So this will have one image like this, and here also due to this have the image like this. Now due to this it will be having some other image like here. So there are many images. Suppose this angle is phi, then you can find number of images by a simple formula. Number of images will be equals to n equals to 360 degree by phi minus 1. 360 degree by phi minus 1. This will be the formula for number of images. Suppose they are at 90 degree. Suppose they are at 90 degree, and a charge is placed, suppose at d distance from here and d distance from here. Then how many images it will be having? It will be having one image like here. Suppose this charge is plus q, so it will having minus q, and due to this here it will be having minus q at the same distance d, here also the same distance d. Now what happened is, due to these two there will be another charge that will be of plus q at the same distance from here and from here. This will be d, right, and from here this will be d. Okay, so this will be the arrangement, and you can also see number of images. What are they? They are 1, 2 and 3 images. You can check from this formula. It is 360 degree divided by the angle is 90 degree minus 1. So 4 minus 1 is 3 images, right? So you can use this formula like this and find how many charges will be there. Okay, so let us see one great question here. A positive charge of 1 nanocoulomb is placed at 0, 0, 0.2 where all distances are in meter. Consider xy plane to be conducting ground plane. Take epsilon value is this. The z component at E. Z component of E at this point is closest to, which one of the following option is closest to the electric field, which is at point 0, 0, 0.1. So we understood the question. What is that? So it is basically based on image theory only. So here conducting surface is like this, and a charge is placed at location 0, 0, 0.2. It is of plus 1 nanocoulomb charge, plus 1 nanocoulomb charge. So and it is at this distance, so its image charge will be where? it will be, it is z equals to 0 surface, because xy plane, so xy plane is z equals to 0 surface, and the image charge will be of minus 1 nanocoulomb, and the location will be 0 0 minus 0.2, right, due to using image theory. So now I want to find the electric field at this point, which is 0 0 0.1, and the z component, what is that? So let us find the electric field due to this charge, the plus 1 nanocoulomb. Suppose that will be E1 is equals to q by, you know that what is the formula, kq by 4 pi epsilon kq by r square. So distance between them, or you can find the displacement vector in fact. So what is that displacement vector? The field location minus source location. So 0.1 minus 0.2, that will give you 0.1. So here I have to write only the magnitude, so 0.1 cube, and here minus 0.1 is z cap, because this is z equal to 0 surface, and so the field direction will be towards the downward. So minus 0.1 az cap, this will be the value of the E1 due to the plus 1 nanocoulomb charge. If I find E2, what it will be? It will be kq by the distance between this. The distance between this is 0.3. If you find this distance, this will come as 0.3. So it will be, this will be 0.3 cube, and the vector will be field location minus source location. If you do, so it will be 0.1, and here uh, this will be 0.3 az cap. 0.1 minus of minus 0.2, that will be 0.3 az cap, and due to this minus I can place here one minus sign, right? So using this, if you solve, E equals to E1 plus E2, E is equals to E1 plus E2. So what it will be? The k value, the k value, what is that? In the question it is given that use epsilon naught is equals to 8.85 10 power minus 12. So we cannot use 9 into 10 to power 9. We have to apply the value of epsilon naught. So it will be 1 by 4 pi epsilon naught into 1 nanocoulomb charge, 1 nanocoulomb charge, because this can be taken common, and what is remaining, it is remaining 1 by 0.1 square minus az cap, and due to this minus, here also minus will come, 1 by 0.3 square az cap. So from the given option, the minus options which are there, that is B and D, will going to be correct. So if you put the value of epsilon naught and solve this, 1 by 4 pi into 8.85 into 10 to the power minus 12, and here if you write 10 raised to minus 9, and if you solve this, it will come as, this will become as minus 1000 by 9, and if you simplify all of this, it will come as minus 999.09 volt per meter. So from the given option, the D option is the correct option. Now let us see our next topic, that is an electric dipole. So what is an electric dipole? An electric dipole is when two charges of equal magnitude but of opposite sign are separated by a small distance, then they form a dipole. So when two equal and opposite charges are separated by a very small distance, this is very small distance, very small distance between them, this d is very small, so this forms an electric dipole. And we will see later that due to this electric dipole in dielectric materials, polarizations happen. So in some materials, in some materials these dipoles are like randomly oriented. These dipoles are randomly oriented. So they are not not in an order in the absence of electric field, when there is no electric field. But when the electric field is applied, suppose in this direction, these dipoles get aligned in the direction of electric field. These dipoles get aligned in the direction of electric field, which leads to polarization, where polarization basically defined as total total dipole moment. What is dipole moment now? Total dipole moment per unit volume. Per unit volume is known as polarization. So what is this dipole moment? So when these charges are placed at a very small distance, they have a certain quantity which is q dot d. q dot d. So this is a dipole moment. Basically this is not dot, because q is a scalar quantity and we just have a q multiplied with d, and here I've taken capital Q. So this will be the dipole moment. Dipole moment. And as you see, this is a vector quantity. Its direction is opposite to the electric field. That is, direction of electric field is positive to negative. The direction of dipole moment is from negative to positive. So this dipole moment leads to polarization, where polarization is defined as the total dipole moment per unit volume. Total dipole moment per unit volume. Let us see, due to a dipole, what is the value of potential at a certain point and electric field due to a dipole. So here is one dipole I have taken, and here this is plus q charge and here it is minus q charge. They are separated by a distance d, and they are present on the z axis as I have taken. So from the origin it is d by 2 distance and it is minus d by 2 distance, and I want to find potential at this point. So I can find first v1, like potential due to this charge at this point. It will be nothing but q by 4 pi epsilon naught, and this distance is what, r1, right? So this will be the value of potential at this point due to this charge. Now what will be the value of potential due to this minus q charge? It will be q by 4 pi epsilon naught r2. So total potential I can find out by v1 plus v2. It will be simply q by 4 pi epsilon naught. This will be common, and here this is actually minus because I'm calculating due to minus negative q. So 1 by r1 minus 1 by r2. This will be the value of potential at point P, right? So V is equals to q by 4 pi epsilon naught r2 minus r1 divided by r1 r2. Now if you see here, this distance is very small. If I draw a perpendicular line from here, from this point to up to, like, wherever this perpendicular becomes 90 degree, like suppose here. So if this is perpendicular, so up to this distance, suppose this is triangle a b, and suppose this point is m. So up to m p, what will be the distance? It is r1 only. It is r1 only, right? And this is a suppose this angle is theta. This angle is theta. So what will be the value of bm? What will be the value of bm? it will be, so it will be bm, if I write bm is equals to this total distance ab cos theta, and ab is what, d, the distance between the charges, d cos theta, right? Now if you see that r2 minus r1, if you solve r2 minus r1, it will be this distance only, r2 minus, because by drawing this perpendicular, this distance up from ap and mp, this will be equal, ap and mp will be equal to r1. So this distance will be remaining, so r2 minus r1, in place of r2 minus r1 I can write d cos theta. I can write what, d cos theta divided by 4 pi epsilon naught r1 r2. Now since this distance between the dipole is very small, I can take this distance as r only, like r1 equals to r2 equals to r, r1 equals to r2 equals to approximately equal, because this distance d is very small. So I can write v is equals to qd cos theta divided by 4 pi epsilon naught r square. This will be the value of potential at a certain point due to, a dipole. Okay, so you can use this expression to find electric potential due to dipole. Now if you remember that electric field electric field is given by minus gradient of v, if you remember this, the previous class I guess. So here gradient, here this is in spherical coordinates, so I will apply the gradient formula of spherical system. So minus I can take out, and what is the formula for gradient in the spherical coordinate? It is del v by del r a r cap plus 1 by r del v by del theta a theta cap plus 1 by r sin theta del v by del phi a phi cap. This will be the value of gradient. Now I will apply this, so I will differentiate this expression with respect to r. So what it will become, here this q d cos theta and 4 pi epsilon is constant, 1 by r square differentiation will become minus 1 by r cube. So it will simply become q d cos theta divided by 4 pi epsilon naught r cube, and 1 by r square differentiation is minus 2 by r cube, so minus 2 will also come here. After that 1 by r, here component I have to write, this is ar component, ar cap. So 1 by r del v by del theta, so in with respect to theta, q d 4 pi epsilon r square will be constant, cos theta differentiation will be minus sin theta. So minus sign will come, q d sin theta divided by 4 pi epsilon naught r square a theta cap. Now if we simplify with it, here minus is there, so I can take this minus common and cancel with the minus. So E electric field will be, I can take few things common, like QD by 4 pi epsilon naught r cube I can take common, here r cube, and here this r and r square will make r cube, and the remaining thing will be 2 cos theta ar cap plus sine theta a theta cap. This will be the value of electric field at a certain point due to a dipole. Okay, so here from the expression of v and e, if you see carefully, that v is directly proportional to r square and e is directly proportional to 1 by r cube. Now if you remember, this is for dipole, actually for dipole. And if you remember that for a point charge V is directly proportional to R and E is directly proportional to 1 by R square for point charge. So what you can conclude from this, for a dipole the potential and electric field decrease faster. For dipole the potential, electric potential and electric field decrease faster with respect to distance, with respect to distance. So if the distance is increased, the electric potential and electric field due to dipole will decrease faster as compared to point charge. Okay, now here if you see, what is this? This is qd cos theta, and if you remember the dot product of uh, suppose here q d dot ar cap, if I write q dot d ar cap, because d vector is for a charge, it is going in the radial direction. So q d dot ar cap, so what it will be, it will be simply q, the magnitude of d, magnitude of ar, that is 1, and angle between them. So in the diagram I have taken the angle as theta here, you see. So it can be simply, I can write this as like this, because, and what is this, this is actually dipole moment. So I can write this as p dot ar. So in the expression of v I can also write like p dot dipole moment dot product with ar divided by 4 pi epsilon naught r square. You can see this expression also in some books. That's why I have told that p dot ar is simply using this identity of dot product here and writing like this. Understood? Okay. So that will be all for today, and we will meet in the next lecture and see few things about dielectrics and also some things about capacitance.